All right, today's lesson in our unit Matter and Chemical Change is topic 5, the periodic table. Right, so the videos we watched in the previous lesson introduced us to Dmitry Mendeleev. So he lived 1834 to 1907. So what happened was it was learned that elements had an atomic mass. An atomic mass is the average mass of an atom of an element, and most periodic tables include the atomic mass of elements. So Mendeleev, he created a system to organize elements in order of increasing atomic mass. But while he was doing that, he also found that the properties of the element repeated at definite or periodic intervals. So this made up chemical families, and that pattern he discovered became known as the periodic table. So Mendeleev was so good at what he was doing that he even left gaps in his table predicting the existence of elements that haven't even been found yet. So he was even able to predict the properties of those unknown elements. All right, then by about 1915, chemists and physics, they started developing those models of atomic structure, and that atomic structure was the key to explaining the periodicity of the chemical properties. So when we look at the periodic table, it was reorganized with a focus on atomic structure rather than just the atomic mass. So the resulting periodic table now is based on a very special number for each element, and it is called the atomic number. All right, so what is the atomic number? So anytime you look at elements on the periodic table, you'll see this number associated with the element. All right, so that atomic number represents the number of protons that an element has in its nucleus. All right, so it's that number of proton that determines what an element is. So every element will have its own unique atomic number. So for example, our first example we're looking at is fluorine. So if you look in your periodic table, I have a snippet of it here. The atomic number of fluorine is 9. So only fluorine will have the atomic number of 9. And that means that fluorine has 9 protons in its nucleus. If we look at oxygen, if you find oxygen on your periodic table, you'll see that the atomic number of oxygen is 8. So oxygen is the only element that will have the atomic number 8. And that means that oxygen has 8 protons in the nucleus. The other thing we know about atoms are neutral. So therefore, if oxygen, for example, has 8 protons, therefore it will have to have 8 electrons to make it neutral. So the positive and negative charges, therefore, will be balanced. So atoms, anytime we talk about elements and atoms, they will contain an equal number of electrons and protons. So therefore, fluorine here, since it has an atomic number of 9, that means it has 9 protons in its nucleus. Therefore, it will also have 9 electrons to keep it neutral. Oxygen has 8 protons. Therefore, oxygen will have 8 electrons, making the atom neutral. All right, another thing to note we'll start talking about is the atomic mass. So if we look at these elements, you're given the element name, its atomic number, its symbol, and then you're given the atomic mass. Same thing here, we have the atomic number, chemical symbol, element name, and the atomic mass. All right, so continuing our talk about protons, neutrons, and electrons. So we know protons are positive, and they're represented with usually like this, P plus. Electrons are negative, usually shown like this, and then electrons, oops, I did that the wrong way. So electrons are negative and neutrons are neutral. All right, and like I said before, protons and neutrons make up the nucleus of the atom. So here we have a diagram. That dense center, that's the nucleus. The nucleus is made up of those green, which are the protons, and blue showing the neutrons, and then the electrons, the negative symbols are shown rotating around the nucleus. Here's another diagram showing the nucleus there in the center, which is made up of the proton and the neutron. And then we have the electrons outside in the electron cloud. Neutral, neutrons, correct. Okay, so what we're going to look at next is the mass number and calculating neutrons. So the mass number is the total number of protons and neutrons in the nucleus. So number of protons, yes, and number of neutrons added together gives us our mass number. Okay, so therefore, if you know the atomic number and you know the mass number, you can calculate the number of neutrons by subtracting the two. All right, so therefore, to calculate neutrons, we're just going to subtract the mass number minus the atomic number. That will give us our number of neutrons. So let's go to the next slide. Example calculations. So let's say we are going to calculate the number of neutrons in the following elements. The mass number is given in the parentheses. So neon, we're told that the mass number of neon is 20. Using your periodic table, find the atomic number of neon. It is number 10, meaning it has 10 protons. So now all we're going to do is subtract mass number minus atomic number to give us the number of neutrons. So 20 minus 10, which is 10 neutrons. If we were doing sodium, sodium has a mass number of 23, and it is number 11 in the periodic table. So that means it has 11 protons. So therefore, when we subtract 23 minus 11, that gives us 12 neutrons. All right, next we're going to talk about how every element has its own number, and every element is part of a group, and every element is part of a period. So we've already talked about groups already. Groups were the vertical columns going all the way up to 18. I'm also shown here, 1 to 18. But every element is also part of a period. The periods are counted horizontally. So if we look on this diagram here, we have period 1, 2, 3, 4, 5, 6, 7. So we can find elements based on which group they are part of and which period they are part of. So for example, if I told you to find the element in group 2 and period 4. Group 2, period 4. So looking at this example here, here would be group 2, here is period 4, so the element would be calcium. Next example, find the element in group 13 and period 3. Group 13, period 3. All right, so we have group 13, period 3. Remember to count here, 1, 2, 3. Yes, it would be aluminum. All right, one more. Find the element in group 8 and period 4. Group 8, period 4. All right, so here's our periods. We have period 4, group 8, and there it is. It is iron. So let's just check our answers on the next slide. So calcium, aluminum, and then iron.